Good day everyone, and I welcome you all to my presentation today. Today's lecture is lecture 18 on the subject of air transportation. The topic related to today's presentation relates to one of the most crucial aspects related to efficient air traffic management, that is on board avionics for CNS. Before going on to our topic at hand, we will first look into the topics that were covered in our previous presentation. The presentation firstly began by providing you details related to the topic of air transportation, air navigation, what are the basics of air navigation. Then we dwelled into what are the two different types of air navigation techniques that are implemented by the pilots, that is visual navigation and instrument navigation. As far as the former topic is concerned, visual navigation techniques, we basically tried to understand what are the two different techniques you implemented within visual navigation, that is pilotage and dead reckoning. After that, the instrument navigation technique topic basically covered topic description of the various instruments that are implemented to carry out instrument navigation. These instruments are collectively called the 6-pack instruments. In the second part of our air navigation topic, we covered we dwelled into the different topics associated with radio navigation, why radio navigation is important, and subsequently we try to understand what are the different equipments and the techniques that are carried out to carry out radio navigation. Most notably, the equipments that we described in the presentation were NDB, VOR, DME, and other navigation technologies like INS and GPS. Let us have an overview of what we will cover in today's presentation. The outline of my presentation today includes will begin by giving you details about the third pillar of efficient air traffic services called surveillance. While covering this topic, we will be basically trying to understand the different types of surveillance techniques that are implemented and what are the different instruments that are integrated with the aircraft to carry out the surveillance processes. Subsequently, we will focus on the most crucial topic related to this presentation, that is the integrated form of communication, navigation and surveillance, that is in layman term called as CNS. Then we will try to understand why such a unification was paramount for the advancement of aviation technology or air traffic management services. Subsequently, the most crucial aspect related to CNS, that is the communication, will be covered in a more detailed fashion, wherein we will describe the various techniques or the propagation paths that are implemented by equipments to carry out voice as well as data communication. Subsequently, the amalgamation of these techniques will be described through two of the most important integrated technologies that are implemented on aircrafts, that is CPDLC and ACARS, which will be described in the latter part of this presentation. So, this is just a brief recap of what Professor Pant had covered previously in lecture 16. So, there are, as we all know, there are three pillars of an efficient air traffic services. Firstly, communication, as to how communication transpires between the aircraft, the pilot as well as the ground crew pertaining to the particular airline. The second pillar, that is navigation, basically covers the technique that is implemented by the aviator to carry out the overall planning and on course correction, so that the flight can be carried out in an efficient manner, so that the related fuel and time consumption is minimized as much as possible. The third pillar associated with this ATS, efficient ATS, is called surveillance. So, surveillance is, we have covered the topic on navigation in the previous slide, and this presentation will begin with by covering the third pillar, that is surveillance. So, what is surveillance? Surveillance is a way by which the air traffic controllers can actually monitor the aircraft within the vicinity of the airport, as well as on course, as well as across different airspaces. So, surveillance basically entails a set of techniques that are implemented by air traffic control services to detect aircraft location for efficient air traffic management. By way of efficient air traffic management, the air traffic controller can provide enhanced situation, can be benefited by the inclusion of enhanced situational awareness of the aircrafts, and what all procedures need to be followed so that safety driven flight operations can be carried out within the vicinity of the airspace. So, how this type of surveillance was basically carried out previously, before the development of radar technologies, most of these the surveillance was carried out across world airports in a visual manner. So, a controller would be sitting in the tower and would subsequently provide ATC clearances and instructions to the aircraft through radio communication while referring to his visual references. However, there was a very big limitation related to this type of surveillance technique. For instance, if the weather related to the airspace in concerned was not suitable or was cloudy, such type of techniques would prove to be unusable, and hence there was a need to carry out advancement in such techniques. Thus, after this type of advancement was further required after the World War II phase, wherein the number of aircrafts that were covering different airspaces had increased. In fact, there was an ongoing demand to implement a technique wherein the different aircrafts could be identified, whether it's a friend aircraft or a foe aircraft. So, in order to cater for these requirements, a new technique of surveillance was developed, which made use of the series of radars that were integrated on the different airports to carry out the overall surveillance. So, it began by making use of the most rudimentary form of radar services, which is called the primary surveillance equipment. How this radar techniques works? Firstly, a signal is transmitted by the radar towards the subject aircraft. This is called the transmitted pulse. Subsequently, based on this interrogation signal, the aircraft in view will send a received signal, based on a reflection from this aircraft, a signal will be received again by the radar, and based on the difference of transmission and receipt of the signal by the radar ground station, the radar could easily track the location of this aircraft. So, this is how the overall tracking system works in the primary radar system. Now, there are different types of surveillance techniques. First technique, which is called the dependent surveillance. In this type of technique, the position related to the aircraft is obtained directly by the aircraft itself. This type of technique makes use of more advanced surveillance technologies like the satellite communication to obtain the overall coordinates, which is subsequently transmitted on to the nearest ATC. And the second type of technique, that is which we already mentioned previously, the independent surveillance technique. In this type of technique, the overall location of the aircraft with respect to the terminal in view is obtained by the ground station itself. So, these make use of the radars to basically obtain the location of the aircraft, which is displayed by the air traffic controller on the display unit with which the ATC personnel have at their disposal, and based on this tracking services, the overall ATC instructions are provided to the aircraft. In the case of independent surveillance, what are the different components that are involved? These are the particular components. Firstly, the aircraft. Aircraft that is being tracked by the radar services. Then the primary radar. This type of radar basically will provide only the position associated with the aircraft, that is the azimuth and the elevation of the, that is the coordinates of the aircraft. However, with time aircrafts have implemented a more advanced version of the radars called the secondary radar services, wherein apart from the position, these type of radars are also able to find the altitude as well as track its find the identity of the aircraft. Now, these identities are basically in pilots term called as squawk codes. Before the initiation of the flight itself, these squawk codes are provided to the particular aircraft, and whenever and subsequently these squawk codes are transmitted to all the nearby ATC towers, so that tracking of whether the aircraft is identified by the aircraft is possible, and hence we can understand whether the aircraft is actually an enemy or a foe. This is how the secondary radar services work. Then the dependent, as I mentioned to you earlier, the dependent surveillance technique make use of the GPS or the satellite or the position obtained by the satellite communication. This data is retrieved by the SATCOM obtained through the satellite and is transmitted onto the aircraft. Subsequently, this data is provided to the nearest ATC, and also through the usage of a special data link communication protocol that is called the ACARS. The particular data is transmitted to the airport ground control station also. The more details related to ACARS will be provided in a latter part of this presentation. So, whatever techniques related to dependent surveillance we understood right now was a more rudimentary method, was a non automatic way, but as the traffic as the air traffic is increasing, in fact it has been found that in 2020 from 2022 to 2023 the air traffic has already increased from by more than 28%, which is projected to go even higher as the year progresses. So, there is an increase in air traffic, because of which the air traffic management is subsequently becoming more and more difficult. In fact, by 2050 with the current the air traffic management services, it will become even more difficult if a more advanced surveillance system is not implemented throughout the globe. Thereby comes the ADS-B technique. This ADS-B technique is the next step which is being implemented by the FAA to carry out a more safer, efficient and greener air traffic management. So, what is ADS-B, you ask? ADS-B firstly includes the term A standing for automatic. Automatic because most of the communication between the pilot and the controller in this type of technique happens automatically. There is no involvement of the pilot or the controller required. Dependent because the overall coordinates that are information that is required for the surveillance is obtained by the onboard sensor systems which are prevailing on the aircraft, as well as the GPS data that is acquired from the GNSS system. Surveillance, because this the amalgamation of all these all the data obtained through these sensors and the GPS SATCOM data is carried out so that the surveillance can be carried out, and the required data in the in a coded form through the usage of a appropriate transponder is broadcasted continuously in the vicinity of the airspace, so that this information can be obtained by the ATC as well as the nearby aircraft, so that efficient air traffic management can be carried out. Let's understand how the ADSB system actually works. Primarily, we know that first surveillance was carried out through the usage of radar. Through the usage of radar. So, the radar would send a signal. Based on the interrogation signal, the aircraft would subsequently send a response signal, but an ADSB system does not include this. It involves the usage of a satellite system, the satellite communication system. So, what happens is that the aircraft obtains the GPS data from the SATCOM, and within the flight management computer of the system, this data obtained from the SATCOM as well as the data obtained from the other other sensors on board the aircraft are combined together, and these are subsequently sent to the nearest ADB ground station. Subsequently, from here onwards, the data obtained is transmitted back to the ATC. So, on the front of the ATC, ATC might have a particular display unit wherein this type of data is readily available to the ATC controller, and based on this communication protocol itself, the overall instructions can be carried out without the need to carry out verbal or voice communication between the ATC and the aircraft itself. More in addition to this type of this service, the ground station, ADSB ground station, subsequently can also transmit back ATIS information to the aircraft. So, when we are talking of ATIS information, which is a short form for automatic terminal information service, it basically includes data associated with the weather conditions prevailing at the aircraft. So, based on this, the overall flight planning can be carried out, and hence is a very important tool to carry out navigation in the current scenario. So, what happens is that if there are two aircrafts in the vicinity of a particular ADSB workstation, both these aircrafts will make use of the ADSB transponder that are system that are placed within the aircraft itself. Information pertaining to the coordinates as well as the sensor data will be transmitted or broadcasted every half second by all the parties involved, that is the aircrafts as well as the ADSB. Now, because these are simultaneously updated and are broadcasted continuously, a more complete and updated picture of the nearby airspace can be obtained by both the aircrafts as well as the ATC control units. So, because of the presence of such a technique which is more automated and is more efficient, there many advantages are associated with the implementation of these techniques. Some of these advantages include the reduced safety distance. So, because of the presence of this automated technique, the safety distance is distance associated with the nearby aircrafts can be reduced. Moreover, because of this, in the traffic management handling has also improved. Because of the efficient handling of the flight routes, there is an underlying advantage associated with reduced fuel and time penalties. Moreover, because of the presence of these automated display units, the ATC controller is able to provide more complex ATC clearances. So, based on the current scenario, the ATC controller can deviate away from the set norms to carry out a particular maneuver which would be required to carry out safety operation of the aircraft. So, these are some of the most notable advantages associated with ADSB. Just to give you a small context on to why it is advantageous, these implementation of these ADSB systems have been found to improve the fuel savings during approach or landing appreciably. So, in a normal sense, while carrying out landing through the implementation of ATC instruction, the landing is more or less like a stepped approach, whereas if the aircraft implements the carries out the landing using an ADSB technique, the landing would be more efficient, requiring lesser time and hence lesser fuel consumption. In fact, it has been found that implementation of such a technique can curtail the fuel consumption by more than fuel consumption that would equalize consumption of fuel consumption of more than 100 cars. So, you can understand how you can envisage how ADSB can be and is being implemented all across the globe to carry out more efficient, greener and manageable air traffic management. So, another part related to dependent surveillance is called the mode C transponder. So, apart these transponders, so we need to understand what is a transponder. So, transponder basically is a transceiver. So, it includes a transmitter as well as a receiver in the same system. So, whenever a signal is sent by the whenever a signal is interrogation signal is sent to a transponder, it is bound to send a response signal. So, this is how a transponder works. In the case of the mode C transponder, this is used to calculate the altitude of the aircraft. This altitude determination is carried out through the usage of ambient pressure. Hence, based on the pressure difference between the current position and the sea level condition, the overall altitude of the aircraft is obtained. So, the overall step includes firstly the mode C transponder, while making use of the radar pulse transmission and reflection, it will obtain the the coordinates of the aircraft, after which the mode C transponder will make use of the altimeter to obtain its altitude, which is subsequently transmitted back to the ATC controller. So, in a nutshell, the ATC controller through the usage of a mode C transponder is able to obtain a more three-dimensional viewpoint of the aircraft positioning and is hence able to carry out the air traffic management in a more efficient manner. So, till now we carried out we tried to understand the surveillance techniques that are used to carry out air traffic management with respect to the ATC controller. Another way of carrying out air traffic management is through usage of techniques through usage of onboard avionics that can help the aircraft to take decisions based on the availability of information related to nearby aircrafts. So, these type of techniques basically is very helpful to carry out surveillance very helpful for the pilots to carry out surveillance of aircrafts nearby. One of such techniques that are implemented by aircraft these days is called the TCAS. TCAS is nothing but the short form of traffic alert and collision avoidance system. This system basically provides continuous traffic monitoring of the nearby airspace, and hence the pilot is much more aware about the airspace irrespective of the ATC controller instructions, and hence it provides an additional hand to the pilot to take decisions which would be required for safe flight operations. This one of the most important application related to this system is that it is very helpful in carrying out in avoiding collision between two aircrafts. how this particular works. In order to understand the working, we need to understand what are the different components involved in this system. Firstly, there are two transmitters that are transmitter receiver that are placed on the upper and the lower surface of the aircrafts, which transmit out signal or interrogation signal in a spatial manner all across the azimuth. Then it also makes use of a dedicated TCAS computer that carries out the underlying calculations, so that the required decisions can be obtained from the system, and hence proper flight operations can be carried out that are required to meet the safety requirements. So, after working out what are the various components, how it actually works. So, as I mentioned to you, there are two transmitters. The first two transmitters associated with the TCAS system. These transmitters, through the usage of two signals that are projected from the upper and lower surfaces, they carry out a continuous survey of the complete airspace, that is airspace corresponding to the upper region as well as airspace corresponding to the lower region. And because of the presence of this even though the TCAS system carries out surveys indefinitely, the system has been designed in a way that the interrogation signal or the inputs to the pilots by the TCAS will be provided only if the aircraft enters within a particular bubble. And hence, continuous tracking of a particular intruder aircraft or the aircraft that has entered into the bubble will be carried out for such aircrafts only, not for all the aircrafts. So, it will basically track only the aircraft that can lead to collision, and hence subsequent warning systems and alert systems will be carried out only for these type of aircrafts. Let us understand again in more detail as to how this works. Suppose this is our aircraft with the associated TCAS bubble. An aircraft enters within its bubble, and this particular aircraft is now projected as an intruder aircraft and will be continuously tracked by the TCAS system. Based on this, an interrogation signal will be sent to the TCAS to the intruder aircraft. In response to this interrogation signal, a response signal will be again sent back to the observing aircraft. Based on the time difference between the transmission and the receipt of these two signals, the overall distance between the two aircrafts can be obtained, and hence moreover, there are other systems that are included in the TCAS computers, that include the system that understands the bearing of the aircraft with respect to the bearing of the intruder aircraft, what is the overall altitude difference between the two aircrafts. These systems act simultaneously together on both the aircrafts, and hence it follows a series of calculations that the TCAS computer simultaneously carries out. After this locking is obtained, the aircraft will continuously track this intruder aircraft. This tracking will include details associated with the altitude, what is the relative bearing of the intruder aircraft, what is the airspeed associated with the intruder aircraft, and the most important aspect related to this system is called the time to collision. Based on the underlying calculations that the two computers carry out, this system basically tries to answer the following three questions. Basically, what is the closest point of arrival? So, when we talk about closest point of arrival, what the system tries to see is what would be the minimum distance, and at what position would the distance be minimum between the two aircrafts. Second question it wants to ask is that aircraft an intruder? When we talk about intruder, that means that whether the aircraft would be intersecting with the route of the traffic aircraft when the CPA point is achieved. The third and the most important question related to TCAS system is what time will such a collision actually happen. Now, what are the different stages of aircraft? Based on all these calculations, there are two different stages of alert and warning system associated with these TCAS systems. First occurs when the aircraft enters within a vicinity of 45 seconds. So, in this particular at this particular point, the TCAS system will only give an alert to the pilot that a particular aircraft is of concern, and the pilot should take note of the presence of this such type of aircraft. The second warning comes when the aircraft is within 5 seconds of the collision. So, at this particular point, a number of oral visual indications will be given to carry out the required maneuver, so that the inevitable collision can be averted. These instructions are these instructions to evade the collision happen simultaneously on both the aircrafts. So, if one of the aircraft is instructed to go pitch up, the other aircraft will simultaneously be instructed to pitch down. So, these both the TCAS computers act in a synergetic fashion, so that the collision can be avoided in an efficient manner. The other type of surveillance system includes, you may say, surveillance system or a warning system that is integrated on the aircraft is called the GPWS. This is a short form for ground proximity warning system. What it does is it basically carries out a regular monitoring of the hazardous flight conditions associated with an aircraft. It operates mostly when the aircraft is within a height of 25 feet to 35 feet to 4 to 5 feet above the ground level. So, whenever such an altitude is obtained, the GPSWS system becomes active, and hence carries out a regular monitoring of the associated hazardous flight conditions. Based on the presence of such a flight condition, the GPWS system will send a visual as well as oral warning signal to the pilots. So, by usage of the by usage of the particular system, the aircraft GPWS system basically carries out a continuous terrain monitoring, and hence provides continuous alerts to the pilots to carry out safe operation of the aircraft within close proximity of a terrain. This in order to carry out or calculate the altitude of the aircraft with respect to the ground, it makes use of the radio altimeter. So, how this radio altimeter works is like, it includes two systems, that two antennas, that is a transmitter and a receiver antenna. First, the transmitter sends out its signal towards the ground. Subsequently, the receiver will receive a signal from that is reflected back from the ground based on so the overall distance or the ground altitude is actually calculated based on the frequency difference between the transmitted and the received signal. So, there are based on all these so now we understood how the GPWS system actually works. Based on the different types of hazardous flight conditions that an aircraft can come about when very close to the ground, there are different modes of GPWS warnings. First mode, that is mode 1, basically pertains to the excessive barometric descent rate. So, when an aircraft is descending at a very steep rate, such type of warnings will be given. Mode 2 warning basically entails warning which is given to the aircraft when the aircraft is approaching the terrain at a very fast rate. Such type of warning is given. Mode 3 warning is given when the altitude, generally what happens during takeoff is that takeoff should ideally occur in a more streamlined or a straight fashion, but there would be certain circumstances like the presence of a gusty condition. The aircraft might not follow a regular straight path, but actually follow a more curved path and hence would undergo altitude loss during takeoff. In such type of scenario, mode 3 of the GPWS system comes into picture. Mode 4A and 4B basically corresponds to the landing scenario. So when your aircraft is approaching land with a landing gear not down condition, this type of this mode basically corresponds to mode 4A, whereas the mode 4B corresponds to a situation when the landing gear is down but the flap configuration is not ideal for the landing condition. Then in that case mode 4B comes into picture. The last mode associated with the GPWS is called the mode 5, wherein if the aircraft deviates away from the actual required glide slope, this type of warning will come into picture. So, till now we have understood what are the three different pillars of overall efficient air traffic management, that is communication, navigation and surveillance. An integration of the three is termed as CNS. Now, we need to understand why the need for such a transition from understanding the three systems differently, separately, and now understanding it in a more integrated manner is necessary. This will be covered in the series of presentation that follows from here onwards. So, what is CNS? CNS is an integrated form of the three systems that relate to ATM, that is communication, navigation and surveillance. So, this unified system basically makes use of more advanced techniques of carrying out the CNS, that is integration of the satellite communication as well as the VHF communication, more advanced version of VHF communication. This type of unification was initially carried out so that more efficient and seamless air traffic management can be carried out in a more global setup. In fact, the importance of the CNS systems cannot be overstated. It is these days a very key technological framework associated with efficient air traffic management. The presence of this system, the presence of such a unified system is very important for safe and efficient operation of aircraft. The region spanning the operation of such systems is not only limited to the terminal but also to the en route airspaces. The en route airspaces include airspaces that correspond to very remote areas also. So, unification of this system is very important for the future of air traffic management. In fact, we can very easily say that CNS to ATM, that is air traffic management, is similar to how a bicycle is to a cyclist. So, in the current scenario, CNS is going to be a very important aspect related to efficient air traffic management and hence needs to be studied in a very hence the need to study such a system arises. So, CNS is a more integrated way of handling the air traffic management, air traffic on a more global level. It provides a more efficient and safe way of airport operation. It provides by way of using this integrated way of air traffic management, more operator friendly routes can be provided to the aircrafts because of the efficiency involved related to more efficient flight routes as well as airport operations. The techniques are helpful in reducing the carbon footprint significantly. Moreover, such type of integration is a very important step towards standardization of on-board equipment. So, in a way I mean to say that aircrafts that are operating globally, but they are transferring but are commuting from one continent to other or one country to other will have the same set of onboard equipments, and because the equipments prevailing across the aircrafts will be the same, standardization of the equipments will be easier, as well as the instructions that are required or the inputs that are required from the ATC or the controller or the pilots will be the same, and hence the communication barrier associated with aircraft operation across different continents or different countries will be reduced as much as possible. So again, why I will again talk about why such an unification of COM, NAV and SIR, that is communication, navigation and surveillance arised in the first step. Previously, as I mentioned to you, most of the three pillars or the three domains of air traffic management were studied or carried out in a separate manner. The whole purpose of carrying out these separately was so that the aircraft can be operated in a redundant manner, and hence safety concerns associated with one of the system getting hampered can be taken care of through such a separate set of systems. However, there has been a significant gap reduction between the application and the spectrum allocated to different system. These gap reductions have become increasingly tangible because of the increasing spectrum of three operations, because of the underlying interference of spectrum associated with the three operations. In fact, there has been such a level of gap reduction that the spectrum allocated to some of the aviation equipments are now overlapping with non-aviation technologies also. For example, we all know about the 5G spectrum. In June 2022, there was a letter written by US airlines that the C band of 5G spectrum is very close to the altimeters or the radio altimeters that are used by aircrafts, and hence there was a need to carry out regulatory changes so that such a scenario could be avoided. This is the level of interference that is coming forth with respect to aviation and non-aviation equipments. Hence, the need to carry out unification so that a standardized way of frequency allocation can be carried out. The second way it is being gap reduction is happening is with respect to the integrated avionics, like the modern aircrafts are these days making use of multifunctional control and display units. So these display units make use of sensors and equipments that rely on frequency spectrum that are very close to each other. Hence, there is a need to carry out a more standardized way of frequency allocation so that such interference between the frequencies associated with different avionics can be mitigated as much as possible. Let's understand the three different parts, the three different components associated with CNS communication. So, communication is nothing but the exchange of voice and data information between the pilot and the air traffic controllers as well as the flight information centers. So, there has to be a interference free clear way of communicating data as well as voice between the three parties involved to carry out efficient air traffic management. So, as I mentioned to you, there has to be a free communication between the aircraft and the ATC controller as well as the flight information center. These information should be able to transmit efficiently many parameters associated with the aircraft that include the position, status, clearance and the instructions that go to and fro between the ATC and the aircraft. The second subsystem, that is navigation, as we had already covered in our previous presentation. It includes techniques that are required to provide accurate, reliable and seamless position determination of the aircraft. That this position should be available readily to the ATC as well as the aircraft, so that proper efficient flight operations can be carried out. You know, the equipments that are implemented to carry out CNS operations these days on aircraft is mainly related to VHF, the operations, that is VOR and SATCOM. We have VOR, mentioned. VOR I mentioned to you in the previous presentation is basically an equipment that makes use of VHF communication to carry out navigation, and whereas the SATCOM navigation system makes use of a constellation of satellites to determine the overall coordinates of the aircraft. The third, so now we will now look into the details associated with the communication subsystem of the aircraft, of the CNS system. This type the communication basically happens in three ways. Either the communication happens through VHF communication or HF, which is more notably called as the airband radio, or the SATCOM communication. The CNS system that is on board the aircraft will select either of the three systems based on the availability in the particular region of operation. So, for instance, if an aircraft is in a close vicinity of an airport, the management unit will switch on to the VHF mode. If the aircraft is operating in a oceanic area or an Atlantic region, it will switch on to an HF mode, whereas if the aircraft is in a region where both these communications are not available, it will automatically switch on to the SATCOM communication mode. So, now we need to understand the three different modes of communication. First is as I mentioned to is called the VHF communication mode, that is the very high frequency mode. This is the most preferred method of communication. So, most of the communications with respect to CNS operations occur using this type of communication. The frequency allocated to such a communication is between 30 to 300 megahertz. So, the system overall makes use of a network of VHF stations that are set up all across the globe, and hence through the usage of these VHF stations, the aircraft is able to communicate to the ATC through direct or through relayed manner. The biggest limitation associated with VHF communication is that its communication is limited by the line of sight constraint. Now, what is line of sight? Suppose there is an aircraft in vicinity and is trying to communicate with the nearest ATC. If the aircraft is in the line of sight of the aircraft will be able to carry out the required communication. But if the aircraft is operating in a mountainous region, the overall fix cannot be obtained, and hence the voice communication will be significantly hampered, and the proper instructions or the information cannot be exchanged between the ATC and the aircraft. Because of the presence of this type of constraint, the overall communication associated with VHF communication mode is constrained up till 300 kilometers only, and is also not available in the polar locations. In order to mitigate these two shortcomings, that is short range and not available on polar regions, the other mode of communication that is used mode that is used by aircrafts is called the high frequency communication mode, which operates in the frequency band of 3 megahertz to 30 megahertz. Now, this has a narrower band width compared to VHF and SATCOM. Now, when we talk about a narrower bandwidth, what we mean to say is that the number of frequency allocations that are possible with HF communication mode is lesser compared to VHF and SATCOM. However, because of the presence of this narrow bandwidth, the underlying interference with other types of communication mode is drastically reduced. As I mentioned to you, these are mostly used in the in the remote locations, that is across the polar region. The third type of communication mode that is globally implemented is called the satellite communication. Now this type of communication mode makes use of two types of satellite constellations. One is called the Inmarsat and the other is called the Iridium. The former basically makes use of a constellation of 15 geostationary satellites, satellites to carry out the voice and data transmission, whereas Iridium makes use of a set of 66 low Earth orbit satellites. The latter covers the complete globe, whereas the Inmarsat cannot be used on the polar regions. So SATCOM basically makes use of these two sets of satellite constellations to carry out data and voice transmission between the aircraft and the ETC. The frequency allocated for such communication mode is between 3 to 30 gigahertz. This type of communication mode has a wider brown bandwidth, and hence the communication particularly related to SATCOM is carried out through on a more global level, and more number of frequencies can be allocated for particular particular application. So let's understand what are the different paths associated with voice communication propagation paths. So there are two types of communication that can happen between the aircraft and the ATC. First is called the voice communication and the other is called the data. First we will try to look into what are the different ways the voice communication happens. Let's understand this with a small context. There is an aircraft, there is a control tower or a transmission tower, then there is the ionospheric layer, which is which I will mention to you, which I will detail to you later. So there are various ways by which the voice communication can happen. First is called the non-ionospheric path or the non-ionospheric communication, which basically makes use of two types of waves. One is called the surface wave and the later second one is called the space wave. The surface waves are basically the waves that follow the path of the aircraft, whereas the space waves are the ones that reach the aircraft after in a direct fashion or in an indirect fashion through reflection from the ground. The second propagation path is called the ionospheric propagation path. These are basically used by two different types of waves, that is the sky waves and the satellite waves. Now the surface waves are basically associated with the signals that correspond to upper end of very low frequency as up till the lower end of very high frequency signals. The range achievable with such type of propagation paths is limited or is dependent on a number of parameters. These parameters include the frequency of operation, the surface over which the wave is traveling, the wave polarization. So as the frequency of the operation increases, the surface attenuation increases and hence the surface wave range reduces. On the other hand, if the communication happens on a oceanic region wherein the surface is more smoother, the range of the communication is increased drastically, whereas if the frequency is very high, such type of communication path or propagation path will not be possible and will be hence absent for all frequencies that operate above high frequency. The space waves, as I mentioned to you, there are two ways such waves occur, that is direct wave and a ground reflected wave. The direct wave reaches the aircraft directly from the transmitter to the aircraft, whereas the ground reflected wave basically is a wave that reaches the aircraft after a particular reflection from the ground. Now, for VHF and all frequencies that are allocated above VHF, only line of sight communication is possible. Thus, the reflected wave operation cannot be made use of for all frequencies operating above VHF. The sky waves, as I mentioned to you, are made up of two components. First component is the wave which is transmitted from the aircraft and it gets reflected back by the ionosphere. The second is called the waves that come from the satellites. So, when we are talking about the sky wave, these waves undergo retardation and refraction, and so let us understand this more in a more elaborate manner. This is our ionosphere. Now, the ionosphere is basically a layer of atmosphere which extends from 60 kilometer till 100 kilometer above the earth, and this type of layer is basically associated with ionized gases, and hence the overall density associated with with this layer is very high. So, what happens is, whenever a ray is transmitted by the antenna, these waves undergo retardation and refraction. The overall refraction is a function of approach angle, frequency and the ionization level. So, when we are talking about the ionization level, it means to say that if the waves propagate the ionization layer in the day, the overall refraction would be higher, whereas in night condition the refraction would be lower. So, ultimately the number of waves reaching the ground will also be determined by the ionization level. So, what happens, as the overall approach angle towards the ionization layer increases, the refraction goes on increasing. Some of these waves go away are able to escape away from the ionization layer, and which are called the escape waves. However, as the angle goes on increasing, the wave undergo more and more refraction, and ultimately at a particular point the waves get reflected back to the ground, and this wave is called the first sky wave, and the distance associated with this the location is called the skip distance. The angle at which such a first sky wave occurs is called the critical angle, and subsequently, as more and more angles more and more signals approach with higher approach angles, more number of sky waves will reach. This is the way how sky waves actually propagate. So, this is a brief tabular summary of the VHF propagation, of the propagation paths that are used for aviation. The VLF band basically makes use of ducting mechanism. So, whereas the LF, MF and MF frequency band make use of the surface wave propagation. The HF makes use of the sky wave propagation, whereas the VHF make use of the space wave propagation to carry out the communication. Now, let us understand the other mode of communication technique that entails transmission or transmission of data between the aircraft and the ground station as well as the ATC. This is carried out by two different types of systems that are incorporated on the system. The first one is called the CPDLC, which is a short form for Controller Pilot Data Link Communication. This is an air to ground data link application. So, this technique, this system is basically made use of to transmit data between the controller and the pilot in an automated fashion, and hence the system is also able to enable exchange of text messages between the controller and the pilot. The second method onboard avionic that is used to carry out data CNS is called the ACAS. This is the short form for Aircraft Communications Addressing and Reporting System. More details related to this system will be given in a later slide. Let's talk in more detail about the first system, that is CPDLC. So, as I mentioned to you earlier also, this is a system that is used by air traffic controllers as well as pilots to carry out transmission of data between the two, and hence the system is able to permit data link messages to be generated for all stages of flight. So, by way of this system, the aircraft can provide details related to different stages of flight, that is during aircraft, when does the aircraft land, when does the aircraft want to approach the nearest airspace, and so subsequently these such type of communications can happen in through data link in a more efficient manner through the usage of this type of system. This type of communication is very useful when the ATC is very far from the aircraft. Hence, for example, if the aircraft is being operated within the oceanic region, voice communication will not be possible. Hence comes into picture the usage of data link communication. So, now let us talk about the various messages that are transmitted between the aircraft and the ATC through CPDLC. The messages that are transmitted through this system may include pre-departure clearances, taxi instructions, takeoff, climb, en route, descent and landing details, as well as emergency and safety messages. So, as you can see, the system is able to provide a very robust way of carrying out data communication, and hence is useful for aircrafts all across the globe to carry out data link communication. One of the examples related to this type of technique is called the FANS-A. This is basically a short form of Future Air Navigation System. This is a particular system that is being implemented on the Airbus and is used comprehensively for many oceanic routes, as well oceanic bound routes which are long haul and where radar coverage is not possible to carry out the particular CNS operations. The other avionic that is used for data link CNS is called the ACAS. ACAS, as I mentioned to you, is the short form of Aircraft Communications Addressing and Reporting System. This is also a digital data link system for transmission of short messages. So, by way of this system, the aircraft can actually carry out data link or transmission of signal from the aircraft to the ground control related to the airline. The overall communication happens in three different ways. Firstly, when the aircraft is in a region where the VHF radio is available, the communication will happen through a VHF communication mode. If the aircraft is operating in a oceanic region, it will make use of the airband radio or the HF propagation path, and if the aircraft is not able to make use of both these techniques, it will switch on to the satellite communication propagation path. Now, we should understand why the origin of ACAS was actually important. When we are talking about ACAS, the communication mostly involves communication between the pilot and the airline ground station. Previously, before the development of ACAS, the data related to where was the aircraft, what was the time of departure, what was the time of landing, these all information was provided by the crew to the ground station manually. So, there was a way by which the flight crew could actually provide inaccurate data. Now this type of ambiguity was leading to increased employment charges. So most of the charges that were paid previously were on a hourly basis. So it was a case that many crew members would actually give a more exaggerated value, and hence the airline would have to pay a more penalized would have to pay more than what is actually required. Hence, moreover, there has been an increase in air traffic that is nearby the particular aircraft, because of which there has been an increased workload on the pilot as well as the ATC. Hence, there was a need to carry out communications in a more automatic manner, thereby the need to implement ACARS. So the stakeholders involved in this type of communication is the aircraft, which makes use of a router to carry out the overall transmission through the air ground subnetwork. The second stakeholder is called the ground station or the airline ground station. This ground station makes use of a network of ground transceivers to carry out the transmission as well as relay the information. Then the third important aspect is the service provider, who basically cover what are the logistics required to carry out the transmission between the aircraft and the ground station. So to understand the different components associated with aircraft, first we will deal onto the onboard equipment, the equipment that are available on the aircraft. First equipment that is available is called the management unit. So it is basically an interface with the flight management guidance system, and hence provides communication, routes the communication to the ground. The second component of aircraft is the data link printer. So what happens is the data that is provided by the ground station to the aircraft, this can be remotely printed on the aircraft itself, so that a more clear understanding of the message that has been transmitted by the ground station can be understood. The third component associated with this ACARS system is called the maintenance computer. So what this does is, this basically provides continuous diagnostic and fault messages to the base, and hence the airline maintenance institutes or organizations can carry out pre-departure preparations on a more in a more readily fashion, and hence preparations for the next flight can be carried out in a more efficient manner. This is a way of optimizing the management of the recursive flight that the airline has to operate. The second stakeholder, that is the ground second component associated with ACARS, is called the ground equipment. Now this ground equipment is a network of transceivers. So these transceivers can transmit as well as receive data as well as voice communication from the aircraft as well as from the ground control station. Then most of the communication that occurs in this is through the usage of VHF communication path. The end system that is related to this ACARS is called the central unit and the land based computer system, which basically decodes the underlying messages, and based on this overall decision instructions are provided to the ground controller, and which is subsequently transmitted back to the aircraft. DSP or the digital service provider is the third most important component of ACARS. Now these are basically responsible for carrying out efficient communication between the ground station and the aircraft through the usage of the network that is being provided by the DSP. There are two types of DSP providers that are used in the aviation industry these days. That is the service provided by SITA and the AirInc. These basically send messages from VHF station to the end systems, and hence make use of a number of ACARS systems to carry out the overall CNS operations. This is a brief summary of the overall ACARS system. Firstly, there is an aircraft which is trying to communicate with the ground station. Then there is a then there are the transceiver, which basically are the transceiver for the data as well as the voice receipt of the voice communication. The voice communication happens in a more in a VHF frequency operation, whereas the data is transmitted through a more wireless communication base, and subsequently the end unit, that is the control unit system, processes the data from both these stations and provides the regular input to the ground station control. The importance of ACARS in aviation these days cannot be overstated. This can be understood by the classic example of how ACARS was very helpful in carrying out investigations related to a very famous accident, that is the one associated with the MH370 aircraft. This aircraft was this aircraft accident basically included the disappearance of MH370 in the Indian Ocean. What happened was that the onboard car system, which was named Classic Aero, was active on board and was regularly trying to contact Inmarsat satellite on an hourly basis. In fact, this particular communication that transpired between the cars and the satellite system was very crucial in finding the end location of the MS-370 aircraft, and based on this itself, the investigators were able to find the final radius within which the MS-370 could have been actually crashed. So, in a way we can say that the ACARS system is a very important tool that is being implemented by the aviation industry to carry out efficient CNS operation throughout the globe. Now, I will now now I will end this presentation with the concluding remarks related to this presentation. We firstly explored what are the different how surveillance is important for efficient air traffic management, what are the and how it is very important to carry out safe, efficient and eco-friendly traffic management. Then we try to understand what are the different types of surveillance systems, that is dependent and independent surveillance systems, and how a more advanced system of dependent surveillance system, that is ADSB, is being implemented by the air traffic services to carry out surveillance, and also how ADSB is actually a key to future air traffic management. Then subsequently we also try to understand the underlying methodology related to different warning systems, that is TCAS and JPWS, what are the principles associated with these two techniques and what are the functions associated with these two techniques. Then we try to understand what is the importance of integrated way of making use of the three pillars of ATS, that is communication, navigation and system, and hence we try to understand the importance of the CNS system. Then the presentation also provided you details about the various communication modes and the paths that are used to carry out communication associated with CNS, and the navigation equipments that are used to carry out the navigation associated with CNS. Subsequently, CPDLC and ACARS for digital data link CNS was also dwelled into in the final part of this presentation. In the end, I would like to conclude this presentation with a quote: "Aviation is a dance between man and machine, where skill, knowledge and intuition intertwine." So, whenever you try to explore the different topics of aviation or try to enter into aviation industry, you keep these things always handy: skill, knowledge and intuition. With these words, I bid adieu, and may you all have a safe day. and a happy day. Thank you. Bye bye.